Okay, welcome back to Physical Science Online. Today we are going to go over distance versus time graphs in a pretty all-encompassing way. Some of this is going to overlap BP, mostly cover BP2 about how to interpret graphs. It's also going to kind of cover our speedwalking lab if you end up doing that in your class, and a couple other things all in one little tight, neat video here is my goal. So what I have going on in the room, you can see, is a grid where I've actually marked out on the floor every 3 tiles, which is about 1 meter. It's not perfect, but it really works well in my classroom to have it just be every 3 tiles. So my point of origin today is this first blue mark. That's going to be point number 0, distance 0, and then the positive direction is going to be going away from the camera. That's my frame of reference. So identifying this point of origin, 0, point 0, and which way I'm going is what we call a frame of reference. And now that I've identified those, we can all talk about the same story. That story is going to be the distance time graph that you can see off to the left. On that distance time graph, we got a couple different things going on. Reminder from the notes, anytime that there is a straight line, that's a constant velocity. Anytime that line changes directions, or curves, I don't have a great example of a curve on here, but I do have a couple of change of directions. That's an acceleration. So you have a new velocity. You're changing velocities. You're changing that constant velocity. That's called an acceleration. Let's see what this graph ends up looking like. And yes, I know I'm not going to be perfectly 10 seconds, but I'm going to kind of try to make this as demonstratable as possible. So on my graph, I start at 0, 0, point 0, 0. It says I walk at 1 meter every second for the first 3 seconds out to 3 meters. So you can see that at 1 meter, I'm at 1 second, 2 meters, I'm at 2 seconds, 3 meters, I'm at 3 seconds. Then in 2 seconds, I go 4 meters. So I go 2 meters per second for the next 2 seconds. And then I stop for 2 seconds. So at 7 meters, I stop for 2 seconds. And then I come back at 3 meters per second until I'm at 1 meter, and then I slow back down to 1 meter per second in the negative direction. So let's see if we can get this to work correctly. Everything I just set up. So 0, 0, 1 meter a second for 3 seconds. So 1, 2, 3, 2 meters a second for 2 seconds. 1, 2, stop for 2 seconds. 1, 2. Then I start coming back in the negative direction. 3 meters per second for 2 seconds. 1, 2, 1, 2. Oh, I went 1 too far. Sorry. And then 1 meter per second for the last second. So yes, I know the time wasn't perfect, but with my, hopefully you're able to hear all that audio. I'm going to double check it before I publish it. Should be a pretty good thing. Let me do it one more time. See if I can hit this real time. I'm not going to focus on the verbal as much. So let's see if I can hit this. 1 meter per second, 2 meters per second, stop. Negative 3 meters per second, negative 3 meters per second, stop, and then 1 meter per second before I stop again. And actually, the end of the graph isn't quite a stop so much as it is when we stopped keeping track of that object. So we have no clue what happened to that object because we have no more data for it. So that's how you interpret these graphs. Positive slope, positive direction, steeper slope is faster, negative slope, negative direction, and horizontal slope is 0. Hopefully that helps. That's all I got for this video. Thanks for watching.